First question. UCL stands for
upper control limit.
very good, beautiful. So hope all of you are also clear with the expansion upper control limit. Anyone here, can you tell me the formula to find out the upper control limit? If you have a data collected from a process, how will you find out the upper control limit?
So for example, we have some tolerance, positive tolerance and negative tolerance, then we will easily find out the upper control limit. For example, 10 number and somebody has given us 0.2, right? It's a plus minus tolerance. Then upper control limit will be 10.2.
No, what you are explaining or what you are talking about are our specification limits.
Sir, can I take this question?
Yes, sir, please.
See, this is the limit given by the customer, specific by the customers, right?
No.
Sorry.
Control limits are calculated from the process data. Whatever customer is giving you, they are known as specification limit. Here we are talking about control limit. Control limits are nothing but the points which are 3 sigma distance away from the center. Average plus 3 times standard deviation. Average plus 3 times standard deviation is the upper control limit. If you go on the left side, average minus 3 times standard deviation, that will be lower control limit. So upper control limit and lower control limits are the extremities of your process or the limits of your process. You can calculate that by collecting data from the process. All of you understand the difference between specification limit and control limit. Let me give an example. Let us say customer wants a rod which should have a diameter of 100 plus or minus 0.5. 100 plus or minus 0.5. Now customer target is 100 mm. Customer specified upper limit, which is upper specification limit, is 100.5. Lower specification limit is 99.5. Right? So these are customer limits. How can I calculate control limits now? I actually produce rods. Let us say I take 10 samples from the production. Now the readings, you have 10 readings. Can you calculate average with the help with the 10 readings?
Yes, sir.
That is called process average. That is called process average. And now you need to calculate standard deviation. Let me say your standard deviation is 0.1. Standard deviation is 0.1. Now what will be your upper control limit? Process average. Process average also, let me give a value. Process average is 100.1. Process average is 100.1. Standard deviation is 0.1. Then upper control limit will be 100.1 plus
1.1.
3 times 0.1, which is 100.4. Am I right?
Yes.
Lower control limit will be 99.8. Now lower control limit is seen inside lower spec. Upper control limit is seen inside upper spec. That means your process, just made it. The process is going to produce acceptable products. That is the understanding, right? So formula is average plus or minus 3 times standard deviation. Hope the previous question, all of you understand. The specification limits are calculated basis the dash limits are calculated basis the actual variation of data, whereas dash are provided by the customer. What will be the answer here?
Control and specific.
Very good. Control limits are calculated using the actual variation of data. If you want to know how is your process performing, you should look at control limit. And is it capable or not? Compare the control limit with the specification limit. If control limit is seen inside, your process is capable. If control limits are seen outside, the process will have rejection. So answer for this question is, I think, option B. The control limits are calculated using actual variation of data, whereas specification limits are provided by the customer. What is the area contained within plus or minus 3 standard deviation of a normal curve?
68%. 68%.
What is the area contained within plus or minus 3 standard deviation of a normal curve?
99.73, sir.
99.73 is the correct answer. If you go up to control limit, you will cover up the major portion of the curve. See here, x-axis and your normal distribution bell curve, right? Your control limit is here. Oh, what happened? Your control limit is here, which is upper control limit. There is one more control limit, lower control limit. Now, what percentage of the curve is inside the control limit? Almost major portion of the curve is inside, right? Am I right? Major portion.
Yes.
So this is called 99.73. If you go up to control limit, almost 100% is covered, but exactly 99.73. But if you go up to 2 sigma limit, 2 sigma here, this is plus 2 sigma and this is minus 2 sigma. These points are called warning limit. Within this, the area under the curve between the warning limits will be 95.45. Suppose if I draw 1 sigma, the area will be 68.27. These are called 1 sigma, minus 1 sigma here, plus 1 sigma here. These are nothing but properties of a normal distribution. Any curve, any normal curve will have this property. What will be there at the center? Can anybody tell me? At the center, the process
Mean.
average, process mean. So hereafter, please remember this number. 68.27% of the curve will be inside 1 sigma limit. Anand, I am muting you because there is some noise coming. So 95.45% of the curve will come under warning limit or 2 sigma limit. But 99.73% of the curve will come under control limit. So if you understand what is happening at the control limit, you almost understand 99.73% of the population. If you know where is your control limit, upper limit and lower limit, you know what are inside the limits. But you still have you do not know what will what are what kind of events will be happening beyond upper control limit. You don't have any clue because you know only up to upper control limit. You calculate upper. So generally, in order to understand any population, we try to understand what will happen at the upper control limit. If what happens at the upper control limit is acceptable, everything is acceptable. At least 99.73% of our population is acceptable, right? That is the idea. Maybe I'll give some additional examples later on. So now, sigma level, choose the incorrect statement. Choose the incorrect statement. Please read and tell me the incorrect statement. Sigma level of the process will decrease if the process becomes off-centered. Sigma level of a process will
C,
increase.
sir.
C would be the correct answer.
अरे उसको साफ सुथरा में तो 2 दिन होटल में रुक के आया था, वो उस पीछे में रहे.
So C, yes, sir.
C, what C is telling? What is sigma
Sigma
level,
level.
first of all?
Standard deviation, sir.
Sigma level is not standard deviation.
No, sigma level is the
Capability.
expected level, capability. When
Ah.
some standard deviation increases, sigma level decreases.
So incorrect statement is sigma level will increase with increase in standard deviation. This is the incorrect statement.
Sorry, sir, we mistook the question. I'm sorry.
True. See, that's how the questions will be. Unless and until you understand the question and also understand the subject, no, you might make mistakes. That's quite normal. So we need to figure out the incorrect statement. See, always, please, all of you understand, sigma means standard deviation. Standard deviation is variability. Sigma level means your capability. Your capability will be more if the variability is less, right? So that is the idea, basis behind this question. Oh God. So this question, we'll take it later. Okay. I think we'll come to that question a little later. The person who leads the effort to improve a process is called, what is his name?
So
D, project lead.
project lead. Why it is
Project
not
lead.
process owner?
Process owner means
Process owner.
see, process owner is the person responsible for the process.
Correct. And
But if an improvement is required,
project lead is
a
required.
green belt or a black belt will be assigned. He will work with the process owner, and then, process will perform better.
Right.
So process owner himself can also be a project leader, nothing wrong. But if you say process owner, he is not leading the project, he is only part of the project. So our correct answer is project leader. All right. Which of the following is not true about a project charter? Again, answer question is
Question is tricky. B
Yeah,
would be the correct answer.
reverse question, right? So B
Yes.
is the correct answer. It is a document that is first created in the defined phase and must not be edited. No, it is not the purpose of project charter. You
It
can
is
update the
updated
project
throughout
charter.
the project.
Yeah, throughout the project. It is called a living document. Project charter, you should have been taught about this, right? Project charter is a living document. As and when a progress is made, you can update. As and when a change is required, you can update. And major change required, you can update and get it reapproved. All right. A problem statement will not mention
D,
D. Reason why the problem exists. Reason why the problem exists is the root cause. Right? So while writing about the problem, we are not supposed to talk about the causes as well as the solution. So D is the correct answer. Hope all of you are with me. Decrease the casting defects from 17% to 5% by the end of January 2020. It is an example of business case, problem statement, goal statement, scope statement.
The
Goal statement.
Goal statement.
Yeah, exactly. Goal
It is goal statement.
defect, casting defect,
Yes, any defect. It follows a principle called SMART: specific, measurable, achievable, relevant, and then time bounded. Which of the following is an important responsibility of a project champion?
It's a C, allocating resources to support the team.
Very good. That is correct. Allocating resources to support the team. That is the main responsibility of the project team. Very good. Dash comes from within the business and dash is provided by the customer.
D,
VOC.
Yeah. Voice of business comes from within the business and voice of customer is provided by the customer. Hope all of you have read this, studied this. If a customer segment complain about a longer transaction, a metric that can be used to track the performance. It's a question with answer.
transaction time.
Customer is worried about transaction, so you work on the transaction time, right? So whatever the customer requirement, you should work on it. So CTQ is transaction time. How are the requirements that will impact customer satisfaction proportionally to their availability? How are the requirements that will impact customer satisfaction proportionally? That means if you perform well, satisfaction will go up. If you perform badly, satisfaction will come down. I think this is a question from Kano model. If that was taught, you might know. It was discussed, right? Performance, very good.
Performance only, sir.
The other name for performance characteristics are one-dimensional characteristics. You can call it one-dimensional characteristics. You can also call it linear satisfier. You can also call it linear satisfier, right? All are same. Linear satisfier means you do well, satisfaction go up. You do badly, satisfaction come down. Your car is giving more mileage, then you'll be more satisfied. Your car performance mileage is going down, your satisfaction will also go down, right? And moreover, all of you need to understand, it is the performance features with which you will compare one product against other product, particularly competitor. You compare a product against the competitor's product using the performance features only. That is why it is called a performance feature. Forming, storming, norming, and performing are the terms that describe stages of team growth. Stages of team growth. We did not spend time separately on this. However, any project you work on, the first step will be forming a team. As soon as you form a team, you know what will happen? They'll fight each other, storm. They may not agree to something, and then you collect data and do some analysis, then things will become normal. Isn't it? Once they see data and things will settle. It is only after the norming stage that team will start performing. As a leader, you need to ensure the first 3 stages goes through in short time, so that majority of the time is available for performance from the team. Otherwise, for storming itself, if they take whole project time, then nothing will happen, right, to your project. So these are terms related to team management and project management. So which of the following best describe internal failure cost? What is internal failure? What is external failure?
D.
The cost resulting from non-conformance. Yes, that is cost of failure. But deducted before dispatching the product, then only it is called internal failure. If the failure is deducted after dispatching the product, then it is called external failure, right? External failure will be more costlier than internal failure. In measurement analysis, which of the following pairs of data measures is used to determine total variation? In measurement system analysis, which of the following pairs of data measure total
Measurement variation and process variation, sir.
Very good. That is the correct answer. Measurement variation and process variation. Any data you collect, that will have a variation.
So the process of measurement.
Yes. One source is process, other source is measurement. The source of process variation is the problem we want to solve. But measurement variation is an artificial, unnecessary problem our measurement system is bringing. Right? That is why we try to control the measurement variation before controlling the process variation. Ultimately, measurement variation plus process variation is equal to total variation. All of you remember this formula. Measurement variation plus process variation is equal to total variation. Right? Which of the following is an example of continuous data? Continuous data means measurable, right?
D, sir. Number of times the customer had to call.
Yeah.
Was the delivery timeline met or not?
Is it continuous data? Delivery timeline met or not? What do you think will be the response?
Boolean.
Diameter of the rod.
Diameter of the rod. All of you, if you are writing exam, you should read the question. You must spend 10 seconds to understand the question. Then only you must answer. You may know the answer, but you may answer correctly. You see here, delivery timeline. They are talking about delivery time, but ultimately data is not delivery time. So here data itself is diameter. Hope all of you understand this question, right? Very simple question, but it was very easy to make a mistake also.
Sir, if the diameter of the rod is not there, na, then the B answer would have come.
No, no.
No, then also not, sir.
What is B? Number of times the customer had to call to get the billing dispute resolved.
Discrete data.
How many times? Number of times you will call a customer care. How do you know? How do you know how many times you called? You have to count, isn't it?
Countable data.
Okay, sir. Okay, sir.
So here diameter is the answer. For a measurement system to be adequate, the percentage gauge R&R and NDC value. What
Less
is
than
the-
10%.
Yes.
Gauge R&R.
Gauge R&R should be less than 10% and NDC must be
Less than
more than
5%.
more than
Greater
5.
than 5%.
Greater than or equal to 5.
NDC must be 5, right? 5 and above.
Greater than.
NDC depends on resolution of a measuring equipment, of the measuring instrument. NDC depends on resolution. What is resolution? The least count. All of you know least count, right? Better the least count, more will be the resolution. Sorry, better the resolution, more will be the NDC. So NDC stands for number of distinct data categories, right? So, and the last will be the answer, right? NDC should be more than 5. Now, which of the following is the correct formula for DPMO, defects per million opportunity?
B.
B is the correct answer. Defect per
10 to the power of
opportunity
6.
into 10 to the power of 6. So second one is the correct answer. Which of the following tool can be utilized to list all probable X? But this is something to do with analyze space. I don't want to take it right now because analyze space we only partly covered, right? Isn't it? So let us take these questions probably next week. So I don't want to trouble you with all these questions. You let us learn and then we'll take it later. So now let us go to some analytical questions. This will be very interesting, right? Dealing with some numbers. The mean and standard deviation of the data set. If I give you a set of number, how many of you will be able to find out the average and standard deviation? All of you,
Yes, sir.
right? Definitely you should be able to find out. How will
So
you do it?
Do we have to calculate or can we use control chart or the?
Sir, you can use Excel, you can
Okay.
use Minitab, and you can use anything that you are comfortable, right? Whatever you know, you can use it. But ultimately, you should be able to find out the mean and standard deviation. Shall we try in Excel?
Yeah, sure. Because
Okay, we'll try in Excel. I will share Excel sheet for that purpose. Hope all of you, do you have the Excel calculator I have shared with you? This calculator, should I have shared with you?
Not that, sir.
Okay.
no.
So I will share it in the your WhatsApp group. Don't worry. Right after the session, I will share. So many things I have typed here. See here the same numbers I have here. Can you see 38, 48, 42, etc., etc. So many numbers up to 44. All right. Now, okay. So let me remove this. So how to find out the mean here? Average is the formula, right? Average. You select all this number and close the bracket. So what is your average? 43.9. Similarly, equal to standard deviation. Standard deviation of population, standard deviation of sample. What we have is sample. So standard deviation of sample, you select this, then you select all the numbers, close the bracket. So there are two answers, 18.05 and then 43.9. All of you, do you understand how I calculated? What is the formula for mean?
Yes, sir.
Average.
Average. If you select the average, it will ask, automatically a bracket will open. You have to select all the data, close the bracket. Now you get the average. Similarly, for standard deviation, you type equal to STD. Automatically this will come, standard deviation of sample. One more time, you select all this, close the bracket, you are getting it. And now let us see the answer here in the PowerPoint. What is the answer now?
For B is the answer.
Option B, sir. B.
B is the correct answer, right? You can also do similar work in Minitab also. Let me show you Minitab also.
Saw some questions even on Minitab usage.
Hello? Yes?
I saw some questions even on Minitab usage.
Yes.
Will
Minitab.
that be a part of the exam as well?
No. They don't, yes, a few questions might require Minitab. Yes.
Because they ask which menu should be used for which
Oh,
calculation.
something like that. Correct. That, yes.
Until
Yes,
we
that's
use
because
that, probably we will not
Minitab
be-
is very popular, in Six Sigma projects. So yes, Minitab also to certain extent we should know. So see here, I'm just typing some number here, whatever it is. Okay, I have some numbers 1, 2, 3, 4, 5, 6, 7. Now I want to calculate some statistics. I can go to stat. I'll go to basic stat. Can you see display descriptive statistics?
Yeah.
Please click that. Now variable, which variable? Column number 5. So column number 5 is selected. Now come to statistics. Can you see so much information, so much statistics available? Right? You know, so much statistics available. Which are all the statistics familiar with you? Are you familiar with the mean?
Yes.
Yes.
I don't know standard error of mean. You are still yet to understand. Standard deviation, all of you know. Okay, variance means
Square root of standard deviation.
square of the standard deviation, not square root. Square of the standard deviation. Coefficient of variation, RK would have taught, right? Coefficient of variation, that also we have not discussed. And sum, all of you know sum.
Yes.
Minimum, maximum, range. I think all these, all of you know. And first quartile. Do you know first quartile? Okay, median, you all know median. Median means the mid value, the center value. And mode, all of you know mode?
Maximum occur.
Maximum occurred.
Repeated.
I think this is what you are familiar so far. Right? So slowly you need to understand the meaning of everything here. Now I give okay. One more time, okay. And now whatever I have picked up, that was calculated. You can see that is calculated. Now, what is the mean for this particular data? 36.11. What is the standard deviation? 10.12. So sum means total. Minimum is 23. Median is 34. What is median? 34. How to get the median? Any idea? We should arrange the number in increasing order or decreasing order, right? Then find out which number is there in the center. In this case, that number is 34. If there are two numbers that stand in the center, you take the average. One more time average. So that is median. The other name for median is quartile 2. What is the other name for median? Quartile 2. So let me type it here. Quartile 2. Quartile 2. So quartile 2 means 50% on the left and 50% on the right. Am I right? Your data will be distributed equally, divided equally. That is called quartile 2. If I say quartile 1, your data 25% of the data will appear on the left side, 75% will appear on the right side of the number. Then it is called quartile 1. All of you are with me?
Yes, sir.
Then please define what is quartile 3.
75.
75%.
3/4 actually.
75% will appear on the left side of the data, left side of your quartile 3, and 25% will appear on the right side of quartile 3. Shall we now see what is quartile 1 and 3 for this particular data? We'll see, right? And interquartile range is nothing but quartile 3 minus quartile 1. Now let me check stat, basic stat, basic stat, display descriptive statistics. Now for the same data, I am going to calculate, only what are required for us. First quartile,
Third.
third quartile. And interquartile range means the difference. Okay, let us only see first quartile, second quartile. And okay, median also we already calculated. Give okay. One more time, okay. Now what is quartile 1? 28.5. What is quartile 3? 43.5. 28.5 is not there in the list. Am I right? 43.5 is also not there in the list. There are some formulas using which they are calculated. Now, below 28.5, how many data points are there? That is what you need to check. Below 28.5.
3 data.
How many data points are there?
23 only, sir.
Only 23.
123 is one thing. Where is it? 23 is one thing. Another thing is
28.
23.
28.
23 and 28. 2 data points out of 8 or 9, isn't it? So you can see 25% of your data appearing below, appearing below 28.5. And so the remaining is 75%. So that is the definition of quartile 1. Similarly, quartile 3 means you can check 43.5. Above 43.5, how many data points are there? 45? 1?
45.
Only 1.
56.
56 also. 2 is there. So this is the meaning of quartile 1 and quartile 3. And this quartile 1 and quartile 3 will appear in box plot. There is a graph called box plot. We go to graph and then box plot. You can see here box plot. I want a simple box plot. Okay. And now the data is column 5. Select and now you give okay. This is called box plot. The center line is the median. What is this line? Median. The bottom line, this is called quartile 1. The top line, this line, that is called quartile 3. All of you understand?
Yes, sir.
In box plot, generally, the Q1, Q2, Q3, and all these things will be used. All right. So we got some idea about some new statistics. And hereafter, with the data, if we come across this, we will be able to calculate. We will be able to understand. Now, the dimension of a particular part should be between 225 and 230. What does it mean? 225 is the lower specification. 230 is the upper specification. Am I correct?
Yes.
An operator collected a sample of 100 parts and process average is 226. Variance is 0.4. Compute ZLT and ZST. These are the options. ZLT, ZST means short-term sigma level and long-term sigma level, right? Always short-term sigma level and long-term sigma level, there will be a difference of 1.5. So one of you, please remember all these numbers. I'll take you to this template and show you how you can use this template. So the numbers 225, 230, and then average is 226, variance is 0.4, right? So I'm going to share the Excel file now. So you can see the Excel file here, right? All of you, can you see the Excel file? Yes?
Not yet.
Oh, not yet. I might have shared something. Oh, I should share the Excel file here. Yeah. Sigma level calculator. You can see here, right?
Yeah.
Now, the data given are lower specification limit, upward specification limit. Lower spec is how much? 225.
225 to the
Upper spec is 230. And then they give average, right? Process average.
226.
And then process variance is given. Yeah, 226. 226, variance is 0.4. Anyone here? Do you know the meaning of variance?
Square root of standard deviation. Square of standard deviation.
Square of standard deviation. Now I want standard deviation. So I will go for square root of
Square root.
variance. When I
Variance.
take square root of variance, I will get the standard deviation. So everything is available. Now come here. Mean, process average. Where is the mean? Mean is X bar. I have selected this. Where is the standard deviation? This 0.63. I have selected standard deviation. Lower spec. Where is lower spec? 225. Upper spec equal to this value. If I do all these things, can you see immediately the Excel is calculating me DPMO? DPMO is how much? 56,923.
Okay.
Sigma level LT, long-term sigma level 1.58. Difference of 1.5. So you add 1.5. Short-term sigma level 3.08. So the short-term sigma level is 3.08. Long-term sigma level is 1.58. Very simple, right? Using this calculator, you don't have to think and break your head. You only learn how to use this. Now let me show you the slide. You can find out the answer easily now.
Sir, one small clarification.
Yes, please.
ZST is equal to ZLT plus 1.5 or it's the other way around?
ZST equal to ZLT plus 1.5. You are right. Always short-term capabilities will be higher than the long-term capabilities.
That's what I wanted to know. Okay, sir. Thank you.
Right? Because short-term capability means everything is fresh, new, so capability will be high. As you use the equipments, as time passes, there will be wear and tear, and so capability will gradually come down. All right. So now what is the answer here in the slide?
C.
C is the correct answer, right? We are not just making guess. We are calculating and finding out correctly. All that required is the Excel file what I am using. If I give it, please download and then keep it safely. You can use it during exam also. Even suppose you take up some examination outside, the same question comes, you answer it. You can use the template, right? So any exam you can crack. Because as far as the Excel template is concerned, it doesn't really matter. Any data you give, it will calculate. Right? It not necessarily be the same question. Now 3,000 dishes are inspected. 60 are found defective. What is your ZST? 3,000 dishes, 60 are defective. You hear in template, there will be 3 situations. Situation 3, bracket, defective. How many samples you checked? 3,000. How many defectives you found? 60. When I type these 2 values, what is this giving me? ZST is how much?
3.55. Yeah.
3.5.
Yeah, you can practice yourself, right? Will you be able to do it if I share the file?
Yes, sir.
The light blue area, you have to, light blue area, you have to type, and the yellow color values will come out as the output. Now, while editing orders over the phone representative must mandatorily check for 6 fields on the order form. How many details he has to check? 6 details. So opportunities for error is how many?
6.
So you have to use situation 1, put 6 here. Opportunity for error, you have to put 6. The quality team sampled 200 calls. So their sample size is 200. Number of samples, 200. After verifying 200 sample, they have found 5 defects. So number of defects found is 5. If you type all these 3 values, Minitab is generating this report. I mean, not Minitab, the Excel is generating this report. You come to know about DPMO, you come to know about DPMO, you also know ZLT is 4.64. When I add 1.5, ZST is 4.14. What is the question? ZLT. So what is the answer here?
2.64.
That's all, right? So I will share the same Excel file with all of you in your respective WhatsApp group, and you can try out all these questions. Maybe this, whatever class right now going on, this recording is also I'm taking. I'll upload it in my channel. If you want, you can.
So ZLT is 2.64.
Yes, that's the answer. It's here. It's coming here. You see.
Yes, sir. Yes, sir. Right.
All right. So the CPCPK, I think CPCPK, yes, to some of you it was not discussed. So I'm keeping it on hold. We can discuss this next week. Okay. Okay. So this is also related to CPCPK. This is hypothesis testing. So I will discuss certain questions after discussing the similar topics with all of you. So right now, this is what I have planned for all of you at the particular level right now. So if there are any questions, specific questions anybody would like to ask, please ask. I will be happy to answer. Any questions? No questions, right? It is always better not to.
All these templates are definitely useful, which we are trying to do it manually for sure. Okay. So
I'm going to share it right, after the class. I'll share it. See here, right now I am in the Minitab platform, right? Minitab screen. So you can learn many things with the help of Minitab. So maybe we still have 15 minutes. So I would like to talk about a very important, concept, normal distribution. All of you, do you know normal distribution? What do you know about normal distribution? The curve will be bell-shaped, right?
Bell-shaped.
The curve will be bell-shaped, right? Let me also show you a bell, right? Go to graph. Go to probability distribution plot. View probability. Okay. View probability. Okay. Now, which distribution you want? So many distribution available. As part of this course, just master this distribution normal. You will be able to deal with other distribution also, normal distribution. So imagine in a class of students that the test mark is normally distributed with the average mark being 70. What is the class average mark?
70.
20.
The standard deviation of the class mark is 5. You all know how to calculate average. You all know how to calculate standard deviation. So I'm giving 70 and 5. I'm going to shaded area. Going to shaded area. And now I'm trying to find out the area between 2 points. Area between 2 points, right? And the 2 points I'm going to choose. This curve, last curve, I'm choosing X value. I want to find out what percentage of the students will be scoring the mark between 65 and 75. What is the class average? 70.
20.
Class standard deviation, 5. We very well know test mark will follow normal distribution. Any measurable characteristics will follow normal distribution. Right? So now I am going to give OK. And now you will be seeing a graph. All of you, can you see the bell curve here? What is the area? What is the red color area?
68.
That means if there are 100 students in the class, 68 students would have scored mark between 65 and 75. This rule will work very well. Why 68 students are coming inside 65, 75? Because average mark is 70. Because standard deviation is 5. All of you understand how normal distribution is helping us? You don't have to look at each and every data point. No, each and every student mark I don't want. I only want class average. I only want class standard deviation. Now, how my class is performing, I could understand. Shall we try to understand what percentage of the students would have scored between 60 and 80? Will you be able to answer?
Yes, we can. Yes.
What will be the percentage? Graph. Please watch this. Root. You can also learn practice. When you practice this many times, automatically you will learn normal distribution. Graph, probability distribution plot. Now I have to choose view probability. I have to give OK. Now I should choose normal here. It is already in normal. And whatever is your class average, you have to give here 70. Standard deviation is 5. Shaded area. between 2 points. Now, instead of 65, I am giving 60. Instead of 75, I am giving 80. If I say 60, how many of you know what is this 60 called? Do you know we have a special name for 60? We have a special name for 60. Anybody know?
Control limit.
Warning limit.
Warning limit.
Because it is 2 sigma away from the average. Am I correct or not?
Correct.
Right.
70 minus 2 standard deviation will give you 60. 70 plus 2 standard deviation will give you 80. When I move away by 2 standard deviation on both sides, what will be the area that will come under warning limit? Any guess?
Rejection area.
Any guess? How much will be?
97 point.
Oh, sir, it is 95%, sir. 2 sigma.
95.45. Please
95.
remember these numbers, right? Give okay. Can you see 95.45 coming?
Yeah.
Only 5% of the students have a chance to score below 60 and score above 80. They are extraordinary students. On the right side, they are brilliant. On the left side, they are dull. Right? So once the class average is known, class standard deviation is known, you can calculate many things. Now, I want to find out. Tell me, do you want to calculate anything now? What percentage of the students will score above 78? Do you think you will be able to calculate? What percentage of the students, or what is the chance for a student to score above 78? Or let me ask a simple question. What is the probability chance for a student to score above 70? Can you tell me? Anybody? If you are part of the class, will you score above 70? What will be your chance to score above 70? You have less chance. You have more. How much?
50%.
Great. Beautiful. Everybody should tell the answer, right? Graph, probability distribution plot, view probability. Okay. Now again, normal 70, 75. Shaded area. Now what is the area we want? Above 70, right? Above 70 means choose this curve. You look at the gray area to the right of the X, right? Click this. Now what should I put here?
75.
70.
78.
70 or 78. Now 70 means center. 78 means some other value. First, let us find out 70. And some of you told correctly. Answer will be 50%. Let us check that. Give okay. Exactly 50%. Can you see? That is the average. It is the average. To the right of the average, you will have 50% of the curve. Similarly, to the left of the average, also 50%. For somebody to score above 70, 50% chance is there. So remaining 50%, he may score below 50. Now let us check for 78. Graph, probability distribution plot, view probability. Okay. Same normal, mean, standard deviation, shaded area. Now instead of 70, what do you want to give? 78. So now I am giving 78. What is the chance for somebody to score above 78? Can you tell me, will it be more than 50% or less than 50%?
20%.
Less than 50%. How much it is exactly? Let us understand. What is the chance for somebody to score above 78?
0.05. 5%.
5.4%. So you can decide well what will happen, right? And how are we predicting all these things? Based on average and standard deviation. If the quality of the average and quality of the standard deviation are too good, your predictions will also be too good. How can you improve the quality of your average, quality of your standard deviation? With the sample size. Take enough samples and with good sampling technique. And with good sampling technique, right? So these two ways you can do that, right? So there are all the properties of normal distribution you can learn practically here. That is the advantage with the Minitab. Graph, probability distribution, one more time, view probability. Okay. I am going to same normal, shaded area. I am taking between 2 points. And now I'm going to control limit left side. What will be the left side control limit now? All of you, please tell me. What is the lower control limit? You must tell very fast by now. Lower control limit will be 55.
55. 60 minus 5.
70 minus 15 is 55.
70 minus 50.
Now upper control limit will be
85.
So what will be the area inside the control limit that is expected to be? Still you have problem, all of you. Now what is the area?
Yeah, 99.7, correct.
So please write these numbers very big in your bedroom. What are the three numbers? One is 68.27. Another one is 95.45.
45, 99.7.
99.73. So 68.27 means the area inside 1 sigma limit. 95.45 means the area inside 2 sigma limit.
2 sigma limit.
99.73 means area inside 3
3
sigma.
sigma limit.
In control chart, we draw control limit. Am I right? We draw upper control limit and lower control limit. What is the chance for a point to appear inside control limit? What is the chance for a point to appear inside control limit of your control chart? 99.73%. That is why we consider, if we see any point outside control limit, we consider it as a special cause. Because there is less chance for a point to appear outside control limit. What is the chance for a point to appear outside control limit? 0.27%. Do you understand? A point easily cannot go beyond control limit. But if that is going, you should alert yourself. Why that is happening in my process? That too frequently, right? So you have to ask yourself. So do all of you now understand normal distribution? So normal distribution is a bell-shaped distribution, right? It's a bell-shaped distribution in which the mean will, the curve, your curve is symmetrical about the mean, nothing but the center. Am I right? The center, the average appears at the center. Your curve will be symmetrical about the center. And 68.27% of the points under the curve will appear or will lie, I should say, will lie inside 1 sigma limits. You all know 1 sigma limits, right? 1 sigma limit means average plus 1 sigma on the right, average minus 1 sigma on the left. If I change the 1 sigma limit to 2 sigma limit, if I change the 1 sigma limit to 2 sigma limit, I change 1 to 2. Then what will happen? The 68.27 will change to
95.45.
95.45. Similarly, I am going to write one more statement. 2 sigma limit, I am changing to 3 sigma. So what will happen to this?
99.73.
Sir, the bell curve between 3 sigma both side is nothing but 6 sigma spread. Can we say like that?
Come again.
If the bell curve is spread from 3 sigma left and right, so can we see the spread is 6 sigma for that particular?
Yes. In any normal distribution curve, the total spread is 3 sigma on the right and 3 sigma on the left. So the spread is 6 sigma. And why we don't study beyond the control limit is only 0.27% chance is there. We sincerely hope that that will not happen in our process. Right? So that's the thing. So this is called control limit. These are called control limits. And 2 sigma limits, what is the name of 2 sigma limits?
Warning limits.
Warnings.
Now please tell me, if control limits overlap with specification limits, what is your opinion about this process? If control limit overlap with specification limits,
It's a 6 sigma because control limit is within the specification limit, right?
First of all of you, you are very clear about specification limit, right? Who will give the specification limit?
Customer.
Customer will give the specification limit.
For example, 100 plus or minus 0.5. 100 plus or minus 0.5. So upper specification limit is 100.5. Lower specification limit is 99.5.
19.5.
Right. Now I am collecting process. I am collecting data from a process. Now I understand upper control limit is also equal to 100.5. Lower control limit is also equal to 99.5. Now what do you understand? You know this formula, right? What is this method? 99.73% of the points under the curve will lie inside 3 sigma limit. Do you know that?
Yes, sir.
Now 99.73% of your products will have dimension between 99.5 and 100.5. Can I say like this? 99.73% of your products will have dimension between 99.5 and 100.5. Why am I telling this? Because my process average is equal to 100. Because my process standard deviation is equal to 0.5. Do you understand? If I get this kind of information from my process, I will immediately write this. 99.73% of my products will be accepted by the customer. My rejection percentage is only 0.27. All of you understand?
Correct.
Correct, sir.
Suppose my sigma is increasing. Right now it is 0.25, no 0.5. My sigma is increasing to 0.75. Now the situation will change. My rejections will be more. Can you see that, all of you?
Yes.
I think this is okay. Wait. Let me put some other value. 100.5, right? Okay. Let me say my standard deviation is this one now. Okay. See, earlier nobody pointed my mistake. This is not standard deviation equal to 0.5. Standard deviation equal to 0.166. Then only upper control limit will come. Then only upper control limit will become 100.5. Am I correct? It should be not even 100.5. Do you understand? 0.16. I multiply by 3. That will be 0.5. Please listen to me.
Yes, sir.
Average is 100. Standard deviation is 0.16. So 3 times standard deviation will be 0.5. Now upper control limit is 100.5. Lower control limit will be 99.5.
10.5.
Now I am creating a scenario where standard deviation is increasing. Earlier it was 0.16. Now let me say it is 0.25. It is increased now. Can you see that? Now what will be your upper control limit? Not even upper control. Wait. Not even upper. Okay, upper control limit. Let us calculate upper control limit. What will be upper control limit?
100.75.
Can you see your control limit going beyond specification limit?
Yes, sir. More than 0.25.
That means rejections is increasing. Similarly, lower control limit will be 99.25.
25.
So in this case, let us calculate warning limit. Warning limit is 2 sigma, right?
What is your W for?
Upper warning limit. Upper warning limit. Warning limit means center plus 2 sigma.
Yes.
100.5. Lower warning limit 99.5. Why I am asking you to calculate warning limit is because for warning limit I have this relationship. What is the relationship? 95.45. Now 95.45% of the products will have dimension between 99.5 and 100.5. That means Remaining is rejection. 4.5% is rejection now. In earlier case, rejection was how much? Rejection is 0.27% only.
0.27. Correct.
Expected rejection 0.2%. But now expected rejection 4 point, how much it is? 5% approximately. Do you understand? We are predicting the rejection percentage by studying a process. We study a process, and if the process control limits are understood and warning limits are understood, you can judge what will be the percentage rejection also. But if the control limit overlap specification limit, this time we call our process as just capable. A process is just capable. Under this situation, CP will be equal to 1. Under the situation, CP will be equal to 1. CPK will also be equal to 1. In case, if CP doubles, okay, let us understand this situation. CP equal to 1, CPK equal to 1. This is called 3 sigma process. This is called 3 sigma process. Control limit is overlapping with specification limit. Now, it assures a success rate of 99.73%. It gives you a success rate of 99.73%. Just with the help of process average and process standard deviation, we are making all these conclusions. This is called inferential statistics. This is called inferential statistics. We use sample and we try to understand the population. We use the sample statistics. Whatever we calculate from the sample, they are called statistics. They are called statistics. The characteristics of the sample are called statistics, and the characteristics of the population are called parameters. What are parameters? The real characteristics of the products we produce. We want to know that. What kind of experience customer will have with my product? I am trying to understand by studying a small sample. And the sample characteristics are called statistics. So statistics, your predictions will be much better if the quality of the samples are better. Do you understand something about normal distribution today?
Yes, sir.
Yes.
Yes. Better.
All right, right. So this is the basics behind, the so many statistics. So we'll be learning. We'll continue to learn in this direction this weekend also, Saturday and Sunday. So that's it from me for today. I think, thank you all for joining in the late evening. So
Sir, one
this,
small doubt, sir.
yeah. Oh yes,
That rejection you said, right, said 0.27%.
yes.
Can you share that again, sir? Because when I see 33% something, I mean, can you say
33%? Come again. 33% is what?
0.33%. 0.27% போட்டிருக்கீங்க சார். அது கொஞ்சம் சொல்ல முடியுமா?
Yeah. See, within control limit, according to the theory, 99.73% of the points should appear.
Oh, that 99.73, that with you minus, and you're telling like that as well.
Yeah, 100 minus 99.73 is 0.27.
Okay, sir. What
Please
I did,
please note, my prediction is based on the sample. Same, if the sample has got limitation, my prediction will also have limitation.
Okay, sir. Because what I did, sir, 100.166 was the limit we said, right, sir? Then the increasing standard deviation. If you go to the, can I show that screen, sir? 1 minute. We do not mind, sir.
Sure. So this one, right?
Yes, sir. Yes, sir.
Yes.
What I did, sir, 100.166 divided by 100. We are increasing the standard deviation, right, sir? So
we are increasing the standard deviation from 0.16 to 0.25.
That I did, sir, actually divided by 100.50, sir. So 99.67 came, sir. Then I thought, okay, 33% only rejection will come.
No. You better try to use the Minitab the way I have explained instead of doing it manually. So Minitab will get you the details. And once you understand, then probably cross-verify with the manual method also. And I will also show one simple case in the manual method. Maybe Saturday or Sunday we will discuss. That time you will understand. So The whatever recordings of the today's class will be posted in my channel separately tomorrow morning. Those of you who would like to get notified, you can subscribe to my channel if it was not done earlier, right? So that you can go
Sir,
through
which
this recording.
channel that app one?
Okay, I will post the link now. Just a minute.